Jessore Higher Maths 2017, question number 5. The three vertices of the triangle ABC are respectively A, 2 minus 4, B, minus 4, 4, and C, 3, 3. In part A, we have to find the equation of the straight line AB. To do this, it's always helpful to draw a diagram. So we can mark in the points A, B, and C and draw the triangle. Now, using the equation of the line formula, for AB, y minus y1 over y2 minus y1 equals x minus x1 over x2 minus x1. And for A, x1 is 2 and y1 is minus 4. And for B, x2 is minus 4 and y2 is 4. So this becomes y minus minus 4 over 4 minus minus 4 equals x minus 2 over minus 4 minus 2. Well, this simplifies to y plus 4 over 8 equals x minus 2 over minus 6. We can cross multiply to get minus 6 into y plus 4 equals 8 into x minus 2, and we can divide both sides by minus 2. So 3 into y plus 4 equals minus 4 into x minus 2. So 3y plus 12 equals minus 4x plus 8. If we subtract 12 from both sides, we get the equation of the line AB is 3y equals minus 4x minus 4. Now in part B, we have to show that triangle ABC is right-angled and isosceles. To do this, it's probably easiest to start by showing that it's isosceles. To calculate the length AC, we can use the formula for the length of a line. It's the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And we're given for A, x1 is 2 and y1 is minus 4. For C, x2 is 3 and y2 is 3. So the length of the line AC is equal to the square root of 3 minus 2 all squared plus 3 minus minus 4 all squared, which is equal to the square root of 1 squared plus 7 squared, or the root of 1 plus 49, and so AC is the square root of 50. Now we can use the same formula to calculate the length BC. For B, we've got x1 equals minus 4, y1 equals 4, and for C, x2 equals 3 and y2 equals 3. So the length of BC is given by the square root of 3 take away minus 4 all squared plus 3 take away 4 squared, which is the square root of 7 squared plus minus 1 squared, which is the square root of 49 plus 1. So the length of BC is also equal to the square root of 50. So we have length AC is square root of 50, length BC is square root of 50. So we have the length of AC equals the length of BC, and the triangle is isosceles. Now, to show that the triangle is right-angled, we can calculate the length of AB. Now we can use the same formula for calculating the length AB, and we have for A, x1 is equal to 2, y1 is equal to minus 4, and for B, x2 is equal to minus 4, y2 is equal to 4. And so the length of AB is equal to the square root of minus 4 minus 2 all squared plus 4 take away minus 4 all squared. And so the length of AB is equal to the square root of minus 6 squared plus 8 squared, which is the root of 36 plus 64, or the root of 100, and so the length AB is equal to 10. Now consider AC squared plus BC squared. That's equal to the root of 50 all squared plus the root of 50 all squared, which is equal to 50 plus 50, which is equal to 100. Now that's equal to AB squared because AB is 10. So that means the angle ACB is a right angle. This is the converse of Pythagoras' theorem. Now for part C, we want to find the radius of a circle whose area is equal to the area of the triangle ABC. Now we know that the triangle has got a right angle at angle C, and so we can take BC as the height and AC as the base. So the area of the triangle is a half the base times the height, so that's equal to a half times root 50 times root 50, which is equal to a half times 50, or 25. Now we know the area of a circle is pi r squared, so that tells us pi r squared is equal to 25. So r squared is equal to 25 over pi, and r is equal to the square root of 25 over pi. Now we can leave that as our answer, but if we work it out, that comes out to be r equals 2.8209, or rounding it off to 3 significant figures, the answer is r equals 2.82.